Okay, factorizing with a leading coefficient, on the x squared. Well, if we take 2x squared plus 4x minus 16, goodness me, what do we do? Yeah, obviously this is a trinomial, so we apply the trinomial factorizing method. No, that's wrong. That is terribly wrong. Highest common factor is always highest priority in every single factorizing scenario. You should end up with something like this. Now this is a bit more familiar. That looks like a trinomial. That's a lot more manageable. Use those big brackets. Those big brackets, they look fancy. They let your teacher know that I know what I'm doing. I know what I'm doing. Look at my big brackets. We're going to take the factor pairings of 8. It's 1 times 8, 2 times 4. I think I've covered my bases there. How do I aim for a plus 2? Well, you know, how on earth do I aim for a plus 2? Well, 1 and 8, that's not going to give me a plus 2. I need something, yeah, maybe plus 4 minus 2. That gives me a plus 2. Plus 4 minus 2. That would be correct. But that's not the point of this video. That was just to show you that you take out a highest common factor regardless. But what if you can't? In this example, 2x squared minus 7x plus 5. We can't divide anything by 2. We can't pull out a 2. 7 is not divisible by 2. 5 is not divisible by 2. Oh my goodness. Oh my goodness. What if I told you that it stays in the same format? We need a binomial multiplied by another binomial, but it's a little bit more tricky. It's a little bit more tricky. This is a prime number. That makes our life so much easier because we can simply say that the factors of 2 is just 1 times 2. Easy stuff. The factors of 5, another prime number. Another prime number. That's just 1 times 5. Now, I like to create this big little x. Now, I know for a fact that there's going to be a 2 and a 1. There has to be a 2x and an x. There has to be a 2x and an x simply to make that x squared. That makes our life so much easier, the fact that there's a prime number. It's beautiful. 1 and 5 is the same. Now we are aiming for a negative 7. But remember, one of these factors are going to be scaled by this 2. When we scale something by 1, it doesn't matter because it just stays the same. But when we scale it by 2, that changes the game completely. So we're aiming for a negative 7. Well, what if I multiplied the 2 by the 5 and put the 1 up here? Well, 2 times 5 is 10. 1 times that is 1. That doesn't really help me. So that doesn't work. Nope, that's not how we would do this. Unfortunately, that's the nature of this method. The nature of this method is to just go through trial and error. Well, 1 times 5 would give me a 5. 2 times 1 will give me a 2. Can I make a negative 7 with a 5 and a 2? Of course I can. Minus, minus 5, minus 2. But I can't put minus 5 and minus 2 in these brackets. That would be incorrect. It would still be 5 and 1. Now, this is the special rule. Pay attention. These numbers cannot be in the same bracket, and vice versa. That cannot be in the same bracket as that. So the 1 and the 5 can't be together, and the 2 and the 1 can't be together. Therefore, the 2 and the 5 need to go together. Remember I said it was minus, 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 minus. That should cover our bases on that one. Well, let's try the next one. Oh, this one sucks. So what if I told you again it's still another binomial by a binomial, but this makes our life a little bit more tough because we have 1 and 4 and 2 and 2. It's not a prime number. And this is also not a prime number. Oh my goodness, that's 1 and 6 and 2 and 3. Now the permutations have just increased on what we can do here. We can either have a 2x and a 2x or a 4x and a 1x, and oh my goodness me, we're aiming for a plus 11. That's the star of the show. This is the star of the show. Well, let's trial and error this. Obviously, if we use the 4 and the 1, I am going to rule out the 6 and the 1 immediately. I mean, that can't work. So let's turn to the 2 and the 3 and see if we can maybe work some magic there. Well, maybe we can put the 3 on this side and the 2 up. Yeah, well, 4 times 3, that would give us a 12. That would give us a 12. Interesting. And that would give us a 2. Can we make an 11 with a 2 and a 12? No, of course we can't. Therefore, this factor pairing doesn't work. Well, what if I inverted it? What if I inverted this pairing? Well, 1 and 3 would give me a 3. 4 and 2 would give me an 8. Can I make a plus 11 with an 8 and a 3? Of course I can. I can go plus 3 plus 8. That would give me a plus 11. So therefore, I would put the 4x and the x. That takes care of the 4 and the 1. That's fine. Remember what I said in the previous question. That cannot be in the same brackets, and vice versa. So the 4 and the 2 need to be separated. Remember, these are positives. You cannot put the plus 8. The plus 8 only comes when you FOIL it. If you put an 8 there, that's just incorrect. That's incorrect mathematics. Okay, well, let's see if we have better luck with the next one. We have 4n squared. And n, why are there n's? Regardless of the variable, the layouts are still the same. It's going to be a binomial by a binomial. And again, we have 1 and 4, and 2 and 2. And again, 1, well, that's beautiful. It's just 1 times 1. I can say without a doubt that this is going to be a 1, and that is going to be a 1. I don't know what the signs are yet. We'll have to wait and see. Well, when I make my big X, I can for certain put 1 and 1 there. That's beautiful. Now, is it 2 and 2, or is it 1 and 4? Let's see. Well, I'm going to lean more towards the 2 and 2. That looks a little bit better. That looks, because we're aiming for a -4, so that looks like it's favoring our way. 2 times 1 is going to be 2. 2 times 1 is going to be 2. Can I make a -4 with a 2 and a 2? Of course I can. -2 makes a -4. Therefore, we'll make these negatives. It doesn't matter on the brackets because everything's identical. That'll be 2n and 2n. 2n minus 1, 2n minus 1 will give me a 4n squared minus 4n plus 1. Common mistakes with this section. That's it. That is it. Plain and simple.